the biggest winners of the next technological revolution may be the companies that nobody is actually talking about in the mainstream media. Every major investment boom in history that has passed us before has created always that same illusion that the most visible innovation captures the most value. We can go back to during the internet revolution, investors, they focus on websites, but much more on the actual durable economic value accumulated underneath them. We're talking semiconductors, we're talking networking, data centers, operating systems, and eventually also centralized cloud infrastructure. Artificial intelligence also today is creating that exact same illusion because the world right now is racing towards larger models, faster chips, and enormous data center build out. But there is a much in-depth problem underneath this, hiding completely underneath the AI revolution that we know. What happens when software stops waiting for humans? What happens when artificial intelligence agents can create an application, access a database, negotiate with another agent, talk in foreign languages between them, but the human cannot understand what these agents are communicating between each other, execute a transaction, purchase computing resources, modify also infrastructure, and continue also operating while nobody is watching 24/7 7 days a week nonstop. At that point then, cloud computing stops being merely a place where applications live. It becomes the environment in which autonomous economic actors operate 24/7. And that creates, in my eyes, a security problem that is fundamentally different from the one cloud computing was designed to solve, because the recent discovery of thousands, and I mean thousands of exposed AWS credentials is therefore more important than the actual number itself when you look at the data. Because Travel Security says they identify more than 64,000 unique AWS keys corresponding to more than 50,000 accounts in its broader analysis, with a subset of roughly 10,600 credentials available also for complete re-verification. Of those, 88% continued to authenticate as of August the 10th, 2026. Just so recently, its analysis identified 768 live keys with full control access across the two highest risk sets that included root credentials and highly privileged IAM identities. This is massive here. The important question here is not simply how many keys were leaked. The important question here is asking is why these credentials capable of controlling enormous amounts of digital infrastructure and can remain valid for years in the process, because this exposes something really at its core, at an in-depth level. The cloud's greatest strength is its centralized control. It's also becoming one of its greatest systemic vulnerabilities. And it's just going to get so much more vulnerable exponentially from here. Because Amazon itself effectively acknowledges the problem. They do. AWS states that anyone possessing valid access keys has the same level of access as the identity associated with those credentials. It recommends also AWS avoiding root access keys and moving workloads towards temporary credentials and IAM roles. This is not an indictment of Amazon. In fact, AWS has spent years building increasingly sophisticated security controls. But the problem now that they're facing is architectural at the core. Because cloud-built computing at its foundation was built around an assumption that made perfect sense where the dominant actors were human and relatively predictable. The software was the human actors. Software is predictable. There will be a company here. There'll be administrators there. There will be applications. There will be credentials. And those credentials would grant access to resources. Simple. But artificial intelligence is changing the identity of the actor as we eventually move to AGI and eventually ACI, ASI. The whole game changes. Because the next generation of software will not simply just execute instructions. It will make decisions. That distinction here is paramount. It's enormous. A conventional application might say use an AWS credential to retrieve a database record because the developer explicitly programmed it to do so. Simple. But an autonomous agent will decide that retrieving the record is necessary to accomplish a larger objective. The first system follows a path, then the second system, what does it do? It pursues an outcome. And when software begins pursuing outcomes, the security boundary around it becomes much more difficult and harder to define. And this is the problem with centralized cloud computing. And this is why AWS incident that occurred with it matters way beyond AWS, because it's an early innings warning here about the collusion between autonomous software and centralized infrastructure. This is just in the first innings. The problems, the breaches are only going to grow exponentially from here, because the traditional cloud model concentrates enormous amounts of authority into a relatively small number of control planes. That concentration produces extraordinary efficiency, and it has worked for many years, where one company can provide computing, storage, networking, databases, identity, and security to millions of organizations. The economic logic is compelling. It has been compelling. The model has worked very well. No two ways about that. Centralization has created economics of scale, has created a productivity boom. It has created and developed advanced economies to grow the development. But centralization also creates what we call concentration of risk. Just say if one credential can unlock an entire environment in that process, then that credential then becomes a strategic asset. If an attacker requires it, the attacker does not need to defeat every server individually. They could potentially inherit the authority already granted to the identity. It's done. It's compromised. And that is why AWS itself describes exposed access keys as a serious security risk and warns that exposed credentials can lead to unauthorized activity and excessive charges. And this is where agentic AI completely changes the equation. And we're moving to the agentic future, because the attacker of the future will not be human sitting at that keyboard. It will be an automated system searching continuously, 24/7, not taking any sick day, continuously looking for exposed credentials, testing them, mapping permissions, discovering valuable data, and attempting to establish persistence. And they will. Google's cloud security research describes the shifts already underway. It's not me just talking about it. Google's already said it's a national security threat. Threat actors are moving towards adaptive tools and AI agents capable of navigating systems with minimal human oversight. Google has also separately introduced new identity and governance controls, specifically because autonomous agents operate at machine speed and interact with sensitive data. And I can say the economic consequences are profound, because humans have limited attention. Some must have an IQ of 100, some must have an IQ of 130, 140, 150. But we're all humans. Machines do not have those limitations. A security engineer may inspect, say, a handful of alerts. Sure, an automated attacker can inspect millions. A human might discover a leaked credential days later. It's already late. An autonomous system would have discovered that immediately. It doesn't matter how good you are as a human. A human may hesitate before exploiting an account because the consequences are unclear. And machines say optimizing for a defined objective has no such hesitation. And this is what I call, from my experience, creates an asymmetry, basically, where the cost of discovering vulnerabilities falls as automation improves in the process. The cost of securing, say, every possible interaction may rise, sure. That is just the beginning of an arms race. This will be an arms race. I can tell you, I could go into deep and make this video 3 hours long. And I could say from history and what it has told us, what happens when the cost of exploiting a system falls dramatically. The system becomes economically attractive to attack. Simple as that. This is the same basic logic behind the industrialization of cybercrime, because automation transforms isolated incidents into scalable processes. AI could accelerate that transformation, and it will accelerate it exponentially. But there's even a deeper issue in all this. The problem is not that AI can attack centralized cloud infrastructure. We get that. What AI will do will multiply the number of legitimate actors that need access to it. Just imagine here an economy, for example, containing millions of autonomous agents. Eventually, we're going to have tens of millions, 100 millions, billions of agents in the long run. One agent manages inventory. Another agent, say, negotiates advertising. Another manages, say, treasury operations. Another, say, writes software. The other agent, say, manages customer relationships, for example. Another, say, purchases cloud capacity. Another monitors and tracks global markets. Another interacts, say, with government systems. Another controls the industrial equipment within the office. The number of machine identities begin to explode. Every identity requires permissions in that whole process that I just talked about. Every permission creates what I call an attack surface. Every credential then in that process creates potential points of failure. Every API becomes a doorway. We just don't have like one API. We have exponential amounts of APIs. And this is why the transition from human-operated software, which we've been used to for the last decades, to agent-operated software is not merely an upgrade in productivity, it's an architectural transition. Because the internet is moving from an environment where humans operate software to an environment where software increasingly operates software. And this is key. It's fundamental. That changes the whole equation, what the infrastructure underneath it must provide. Because the old question was, can this system execute the instruction? Sure. But the new question becomes, can this system here safely allow autonomous software? Those are not the same questions. And this is where the Internet Computer Protocol becomes intellectually interesting. Not because ICP automatically eliminates a cybersecurity risk. It does not. No architecture eliminates every risk 100% of the time. The stronger argument is that decentralized cloud compute infrastructure introduces a different security model at its core for a world in which autonomous software becomes increasingly important and paramount, because the Internet Computer here takes a completely radically different approach to the cloud. Instead of treating, say, servers that we own and administer, say, by a centralized cloud like AWS that we're talking here, or Microsoft Azure, provider as a fundamental unit, it uses what we call a decentralized network of independent node operators around the world and replicated also within execution environments. If the applications also then run inside what we call protocols called canisters, software containers, basically that combine code and persistent state, the network then replicates and validates computation, that decentralized computation across subnets, rather than having to rely on, say, one centralized machine or administrator in that process. And this obviously changes the complete trust model at the core. Because in conventional centralized cloud computing, the organization itself, say for example, AWS or Google Cloud, ultimately trusts the cloud provider. You have to ultimately trust the cloud provider's infrastructure and its administrative controls and terms of policies for that case. But within decentralized infrastructure, like ICP, trust has shifted towards protocol rules, cryptography, consensus, and distributed operators. That distinction becomes increasingly important as a value-controlled software will exponentially increase, because the biggest future security question may not be which company, say, owns a service. It will be which prevents any single party from changing the system. And this is where cryptography becomes more important than corporate policy, because the internet computers chain key cryptography uses what we call threshold signatures, in which signing, say, authority is distributed across replicas rather than concentrated in, say, one private key. And the protocol's documentation also describes at its core that ICP has the ability within secret signing capabilities to divide among nodes. So compromised nodes alone cannot forge valid signatures. And that is paramount here. It cannot forge signatures. And that matters enormously when we are going to move to agentic autonomous systems. Consider the difference here. An autonomous agency operating inside, say, a conventional environment may eventually, it will need credentials to access external services. Those credentials become secrets. Those secrets therefore have to be stored. Those secrets maybe have to be rotated. Those secrets then obviously could be potentially be leaked. The security model becomes increasingly dependent on keeping secrets, obviously secrets. But cryptographic protocols can completely move the security boundary. Instead of asking one machine to possess the entire authority required to sign something, the authority can be therefore distributed across a network. And the result's not perfect security. It's something more valuable here, the removal of certain single points of failure. And this is the core reason, the massive core reason of why decentralized infrastructure will become complementary to centralized cloud rather than simply competing with it. And this distinction is critical. The future is unlikely to be AWS versus ICP. I don't see it. I don't see that in the future. I see a more realistic future is AWS plus the centralized infrastructure, cloud engines. Centralized clouds will remain extraordinarily important. They have enormous advantages, of course, in scale, hardware, availability, enterprise integration, developer tooling, and obviously massive capital investment behind them. The mistake will be assuming that those advantages mean centralized cloud must eventually provide every layer of digital economy. It most likely will not. Rarely, history works that way also. The internet did not eliminate telecommunications. The cloud did not eliminate physical data centers. Public blockchains did not eliminate banks. They're still here. And decentralized infrastructure does not need to eliminate AWS to become fundamentally strategically important. It only needs to become the preferred architecture for particular classes of workloads where sovereignty, verifiability, resilience of safety, autonomous execution are important over, and that provides the security where centralized infrastructure cannot provide. Then this is a much more realistic approach when assessing the future. And I expect it to be a hybrid future of such, because the rise of AI makes those workloads increasingly important. You will need sovereignty, verifiability, resilience, autonomous execution in an AI environment. Autonomous agents handling a company's marketing campaign is one thing, but an autonomous agent, and when they can say control treasury assets, when we have agents, we have 24/7 markets, we have stable coins, operating 24/7, CBDCs operating 24/7. We've got instant transactions. We're going to have billions and trillions flowing through here. An agent also controlling industrial infrastructure, and they will. An agent holding intellectual property that is worth exponential amounts of value. An agent managing a digital identity is also another. Or digital identities, and the higher economic value of the agent's actions, the more important the infrastructure underneath that agent will become. And this creates an economic principle that is easy to miss here in my discussion, because when intelligence becomes abundance, and it will, trust becomes scarce. It's simple as that. Because the world has spent the last decades, many decades, making computation cheaper. But the next bottleneck will be providing that computation behaves correctly. Because we know AI can generate code, AI can generate transactions, AI can generate contracts, AI can generate applications. But who verifies them? Who controls the infrastructure? Who owns the data? Who can change the software? Who can shut it down? Who can alter the database? Who can revoke the identity? Who can see the activity? These are not philosophical questions, not at all. They become balance sheet questions when autonomous software starts controlling billions and trillions of money and business operations globally as we head into the singularity. We're looking at things over the next 5, 10 years, not today, not tomorrow. There's no short-term forecast, because the concept of sovereign cloud engines here becomes paramount at the core, as I just mentioned before, because Internet Computer's current architecture allows an actual user to configure what we call a sovereign cloud engine. Think about this as a dedicated slice of network capacity where the operator themselves can select underlying hardware, say geography, replication characteristics, that begin to resemble something very different, say. This resembles something very, 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 very different from the old debate between public cloud and private cloud. As I said, this is a hybrid approach, a hybrid model approach where a company could continue, say, using AWS freely for their workloads. They don't have to change their workloads, none whatsoever. Centralized scale makes obviously economic sense. It could use then on running cloud engines, decentralized infrastructure for workloads where sovereignty, verifiability, and resilience become more important and paramount within their operations. It could basically connect the two together. This ultimately is a much more powerful thesis from my educated analysis of the situation and why I see things going. Not decentralized cloud replacing centralized cloud, but decentralized cloud becoming the security and sovereignty layer that centralized cloud cannot economically provide by itself. Think about the analogy with the financial system, and I keep it very simple. Banks here did not disappear when central clearing systems emerged. They didn't. Instead, what happened was layers of infrastructures were created when clearing systems were created to reduce counterparty risk, because that then improved settlement and made the system all more resilient. And that same logic will eventually emerge in computing, where centralized clouds provide enormous computational economies and decentralized networks, cloud engines providing alternative trust and execution guarantees. And the combination here becomes more powerful than either architecture alone. This is also why AI agents economy will accelerate adoption, because the Internet Computer is specifically at the core positioning its architecture around agent native software. It's preparing for the agent agentic autonomous future. Its current development materials also describe the network as a sovereign cloud for AI native applications, while its documentation provides infrastructure for agents to build and deploy applications on the network. Its LLM canister architecture also demonstrates at the core an important direction. AI inference can be integrated into the network without requiring an external API key for the application itself. Again, this does not mean every AI model will run ICP. It definitely will not. It does not mean centralized AI disappears. It definitely will not. And it certainly does not mean adoption is guaranteed simply because ICP technology exists. But the strongest counterargument to all this is obvious. Centralized cloud providers can adapt. AWS can improve systems. Sure. Microsoft can harden Azure. Google can redesign agent security. I'm sure they will. Hardware can gain security enclaves. Credentials can come, say, ephemeral. Say, AI agents can be sandboxed. Permission systems also can become far more granular. And all those things are already happening. They're already working on that. So why would decentralized infrastructure be necessary? Because security improvements inside a centralized architecture does not, and I mean does not, eliminate concentration risks. They can reduce it, and that distinction matters massively. Because a perfect managed centralized cloud may be extremely secure, but the economic value of reducing, say, depends on any single infrastructure provider increases as the consequences of failure increase. And this is the same reason companies diversify suppliers, not because the primary supplier is necessarily bad, not at all, but because dependence itself has a cost. And where I believe the more important AI becomes, and it will become important as we shift from AGI to eventually ASI over the next 2-3 years, based on my research, the more expensive that dependence becomes, and that therefore creates what I call second order effects, where we're going to have, where AI will exponentially increase productivity. Productivity in turn increases, say, digital activity. More digital activity in turn then increases the amount of economic value controlled by software itself. More value then controlled by software. What does it do? It increases the consequences of infrastructure failure. High consequences increase the value of resilient infrastructure. And this is what we call a feedback loop. Therefore, AI does not merely create demand for computing. And what it does, it creates demand for trustworthy computing. And this is a much larger market here. And this is why I believe, from my educated thesis, the strongest thesis for internet computer adoption is not that ICP will somehow defeat Amazon. Not at all. That is a wrong mental mode from my educated opinion. The stronger thesis and all that is that the economic system is moving toward a world where centralized infrastructure alone will become insufficient for certain classes of future digital activity in a agentic autonomous world of AGI and shift eventually to ASI. And autonomous agents, when they will multiply, the world will require infrastructure that can answer questions where centralized architecture struggles to answer elegantly. Basically, who owns actual software? Who controls the infrastructure? Can the application be altered without authorization? You tell me. Can you answer that question? Can the system continue operating? Just say if one provider fails. This move in a war where the east and west is shifting. Kinetic warfare is accelerating on different continents. Can execution also be independently verified? And can digital assets be controlled without handing a private key to a centralized intermediary? And can an autonomous agentic operate also without becoming dependent on fragile collection of API credentials? I can just go on and on and on. But these are precisely the areas where decentralized computing becomes strategically relevant. And this is where the AWS credential story connects to the broader AI thesis here. Because thousands of exposed credentials are not evidence that AWS is failing. Not at all. They're the evidence that the old credential-based security model has limits. It has massive limitations. And those limitations are only going to grow exponentially because the coming AI economy will multiply the number of machine actors exponentially. You haven't seen anything yet. It will multiply interactions, credentials, permissions, and it will also multiply the speed at which mistakes and attacks can propagate. And this is where people should not see the opportunity cost in all this, because the security architecture, therefore, will have to evolve around this new economic architecture. And this is the greatest opportunity cost. Because when you think about it, and we'll go back to the Industrial Revolution, It required stronger rails. It required electrical grids and financial institutions to operate. The internet, what did it require at its foundational core? Fiber networks, DNS, data centers, centralized cloud infrastructure. But the upcoming AI revolution requires something much more subtle. It will require core infrastructure that can establish trust between machines that increasingly act without humans. And that there is the real exponential opportunity, not blockchain for its own sake. No, not decentralization as an ideology. Not at all. Infrastructure, trust infrastructure, identity infrastructure. As we move into stablecoins, CBDCs in certain parts of the continent, that will be all interlinked with trust and identity infrastructure, execution infrastructure, settlement infrastructure, and sovereign infrastructure. We can already see the news with Switzerland, with Pakistan, with the world moving away from globalism into mercantilism, where we're going to break up of the East and the West. Sovereignty is becoming paramount. We're moving back to Hamiltonism, where the US is going to reshore, and it's going to be a competition between the East and the West. Who is going to win the race for ASO? And the internet computer is just one attempt to build that layer. Whether it ultimately becomes here, the dominant implementation remains uncertain. I get it. That is where the intellectual honesty matters. I get it. The thesis could fail. Nothing is 100%. But centralized cloud providers could solve agent security more effectively than expected. Enterprise customers could prioritize convenience over sovereignty. Decentralized networks could remain too expensive, too complex, or too difficult to integrate. I get it. Developers could continue choosing centralized platforms because networks are extremely powerful. But ICP was built at its core that it's not complex to run. It can be integrated where you don't even know that you're using ICP, and it's cheap to run. A lot of people, from my educated opinion, will be using ICP without even knowing they are using ICP. It will just be operated in the background. Because the more successful AI becomes, and it will, the more valuable decentralized infrastructure becomes, precisely because AI succeeds. And that's a paradox here. Because AI will strengthen centralized cloud providers in the short term while simultaneously creating long-term economic demand for the alternative infrastructure. That's to keep it safe. Amazon may continue winning the cloud market, and yet the market for decentralized cloud will still grow exponentially by 2030 and onwards. Those statements are not contradictory. They are complementary. The question is not whether centralized cloud disappears, because it's not going to disappear. The question is whether the world's most important software will depend entirely on centralized cloud at its exact moment software itself becomes autonomous. And that is a much harder question, because an AWS credential exposure gives us an early glimpse of why this matters. Because a leak credential may compromise a company, but tomorrow, and eventually in the future, when an autonomous attacker could discover it and understand its permissions and exploit it and move it through an environment before a human security team has even opened alert, at the same time, legitimate autonomous agents will be demanding greater access to increasingly valuable resources. So the threat vector is only going to grow exponentially from here. It's going to grow massively, the threat vector. So at the end of the day, the same technology that creates unprecedented productivity can therefore create unprecedented concentration of digital authority. And that's the most important factor here, because the winners of the agentic economy, that may not simply be companies building the smartest models. It will be infrastructure networks that are capable of making autonomous intelligence trustworthy. Because intelligence without trust is dangerous. Intelligence without ownership is dependency. Intelligence without sovereignty is centralization. And intelligence without secure infrastructure cannot become a functioning economy. And this is why I do not think it's a computer thesis should be understood as a bet against Amazon. Not at all. It's better understood as a bet on what happens after the cloud. Because the first cloud revolution was computing for private service and centralized platforms. The next revolution will distribute parts of that computing layer across networks whose rules are enforced by cryptography rather than, say, a single corporate administrator. And the catalyst will be AI. Not because AI makes decentralization fashionable, not at all. Because AI makes the underlying problem unavoidable. Nothing is going to be stopping the move to an agentic autonomous future where we go to AGI ASI. Because once the machines begin acting economically on our behalf and they rule 24/7, the infrastructure controlling those machines become part of the economic system itself. And at that point, Infrastructure is no longer merely just technology. It becomes governance, security. What does it become? It becomes settlement, ownership. And at the core, it becomes sovereignty. And this is what was the building foundation of the internet, world, computer, ICP, everything on chain, front end to back end, built on trust. And history rarely rewards those who simply identify the next great technology. It rewards those who identify the infrastructure that technology cannot function without. Remember those words in the next 1, 2, 3, 4, 5 years, because railroads outlived the steam engines. History repeats itself. Electricity outlived the light bulb. Cloud computing outlived the websites that first made the internet famous. And artificial intelligence may follow the same pattern. And it will. Years from now, investors may discover that the most valuable part of artificial intelligence revolution was never the intelligence itself. It was the actual core architecture that allowed the intelligence to actually become an economy. And when that future arrives, and it will, over the next 2-3 years as we move from AGI to ASI, the most important investment question will be, and will not be, which AI model is the smartest. You're asking the wrong questions here. It will be which infrastructure billions of autonomous decisions quietly choose to live every single day. And if you find this kind of institutional level analysis that goes well beyond the headlines and the mainstream crypto media, and we actually focus on in-depth forces shaping markets, consider subscribing, comment. Every week, I try to take my time to explore the intersections, obviously, of macro, technology, finance, and artificial intelligence to give you a more in-depth vision of where I see things going from my perspective, to give you a clear vision of how I see the future from my own eyes. And remember to stay decentralized. And thank you for watching. And I'll see you on the next video. Until next time.